I'm Jhayza. So in today's video, we're going to discuss to you about linear programming, ways to solve it, and examples for you to better understand.
I'll give you the floor to Keane to have a short introduction about linear programming.
What is linear programming? Linear problems in general are concerned with the use or allocation of scarce resources like labor, materials, and capital in the best possible manner so that the costs are minimized or profits are maximized. We use linear programming in order to find the optimal solution. There are different methods in order to find the optimal LV solution. One of those methods are graphical and simplex methods. In this video, we're going to explain to you the graphical method. The graphical method is applicable only when we have two variables. We are going to give you two examples of graphical method. First is maximization problem, which will be explained by Jhayza, and minimization problem, which will be explained by Sharine.
So for our first example, an airline offers coach and first class tickets. For the airline to be profitable, it must sell a minimum of 25 first class tickets and a minimum of 40 coach tickets. The company makes a profit of $225 for each coach ticket and $200 for each first class ticket. At most, the plane has a capacity of 150 travelers. How many of each ticket should be sold in order to maximize profits? Step is to identify the unknown quantities. We are asked to find the number of tickets that should be sold. Since there are coach and first class tickets, we identify those as the unknowns. So we have here, let X be the number of coach tickets and Y be the number of first class tickets. Next, we need to identify the objective function. Since the goal is to maximize profits, our objective is identified. So, objective function maximize profit $225 for coach tickets plus $200 for first class tickets. Then, identify the constraints. In this case, we have the following constraints. So, this is our constraints. The non-negativity constraints means that the variables x and y should be positive value only. So it's not advisable to have a negative value for your variables. Thus, the objective function along the three mathematical constraint is maximize x plus subject to the constraints, which is y at least 25 first class tickets, x at least 40 coach tickets, and no more than 150 people. And now we will plot each of the inequalities. Now that we have our inequalities, we will plot them in our Cartesian plane. So in constraint 1, this is 0, 25, constraint 2, 40, 0, and constraint 3, 150, 0, 0, 150. So this will be constraint 1, constraint 2, and constraint 3. This area is called the feasible region. It is called feasible region because it satisfies all the 3 constraints. In order for us to identify our optimal solution, we must know our corner points. So this point A, point B, and point C will be our corner points. These are called corner points because the points falls along the corner of the feasible region. So in order to find the value of these points, we will solve it by algebra. So in point A lies in constraint 2 and constraint 3. So we have here constraint 1 constraint 2 which is x is equals to 40, and constraint 3, x plus y is equals to 150. We will substitute x is equals to 40 to constraint 3. So 40 plus y. So therefore, point A lies on x will be 40 and y is 110. On point B lies on constraint 1 and constraint 2. So constraint 1 is y is equals to 25, and constraint 2 is x is equals to 40. So the points of B is 40 and 25. Lastly, on point C lies on constraint 3 and constraint 1. Constraint 1, y is equals to 25. Constraint 3, x plus y is equals to 150. Substitute y is equals to 25 to constraint 3. And now we have the value of point C, the 1, 2, 5, and 25. To verify the winner, we must see which of these three points maximizes the objective function. So I have here a table which has a corner points and objective function. As you can see in the table, I substituted all the corner points to the objective function, $225 and $200, and the result is that point C has the optimal solution.